Algebra 2, Lesson 4.5a, Solving Polynomial Equations. So what we're going to do is we're going to use all the solving and factoring skills we've learned in Chapter 3 and 4 so far to try and solve these different types of polynomials. Okay? So let's take a look at number 1 here. So first of all, we need to make sure the problem equals 0. So number 1 already equals 0, so we're okay. And then the first step in factoring, right? So we want to try and factor this if we can, right? So we're going to try and factor this. So it looks like there's a GCF I can take out, right? So always take out the GCF. It's the first step in factoring. So we end up with 2x as our GCF. Then we're going to end up with x squared, right? Minus 6x, and then plus 9 is equal to 0. Okay? Now, x squared minus 6x plus 9, we need to try and factor this, right? Because this is a quadratic that we factored before. So we're going to use the x to factor this. So a times c, that gives us 9, trying to get a negative 6. So it looks like what's going to work for us? Negative 3 times negative 3, right? Divide by a, which is 1. So our factors are going to be x minus 3 times x minus 3. And don't forget your GCF here. Now, the GCF here has a x, right? So anything with an x, you have to make it equal 0. So since the GCF has an x, we have to make it equal 0. The x minus 3, we need to know when that's going to equal 0. And the other x minus 3, we need to know when that will equal 0. Alright, so we divide by 2 here. So x equals 0 is one solution. Add 3 to both sides. X equals 3. Over here, x equals 3. Okay? So since the 3 repeats, you really only need to write it one time. So your solutions are 0 and 3. Okay? Alright, so let's take a look at number 2 here. So we're solving this problem now, this polynomial. So first let's make the problem equal 0. Okay? So I'm going to minus, right, 5x squared to both sides. And when you set it up, make sure that it's in the correct order. It should go from highest exponent to lowest. So 6x to the third minus 5x squared, then minus x. Okay? So now I need to try and factor this. So I'm going to look for a GCF. So I do see a GCF. I can take out the x. So then I'll get 6x squared minus 5x minus 1. Okay, now I need to try and factor this trinomial. So I'll use the x method. A times c, that's going to give me negative 6. I'm trying to get a negative 5. So it looks like negative 6, positive 1 works. I have to divide by a, which is 6 this time. So I'm going to reduce this fraction to negative 1 over 1. So my factors will be x minus 1 and 6x plus 1 equals 0. And remember, anything with an x, any factor with an x, we have to set it equal to 0. So x equals 0, x minus 1 equals 0, and 6x plus 1 equals 0. So x minus x equals 0 is one solution. We have that one. So add 1 to both sides. X equals 1 over here. Minus 1, then divide by 6. So negative 1 over 6. So these three are your solutions right here. Okay? Alright, number 3 here. So first we need to make the problem equal 0. So we have 2x to the third minus 8x is equal to 0. Now we need to factor this, so let's take out the GCF. So 2x, right? So we're going to end up with x squared minus 4 is equal to 0. Then I recognize this is a difference of squares here. So if I factor this, this is x plus 2, x minus 2. Now we take each factor, make it equal 0, right? So divide by 2 here. So x is just going to be 0. X is going to be negative 2. And x is going to be positive 2. Okay? Alright, number 4 here. So let's solve this. So I'm going to make it equal 0 first. So I'm going to minus the 9x squared to both sides. So let's make sure we put in the correct order from highest exponent to lowest. So 6x to the fourth minus 15x to the third minus 9x squared is equal to 0. Then now I'm going to look for a GCF, take that out. So it looks like I can take out a 3x squared, right? And then I have, that's going to be 2x squared minus 5x, and then minus 3 is equal to 0. Okay? Then I'm going to factor this trinomial using the x. So a times c is going to give me negative 6. I'm trying to get negative 5. So it looks like negative 6, positive 1. Looks like that works. Divide by a, which is 2. Reduce this fraction, so negative 3 over 1. So my factors are going to be x minus 3, and the other one is 2x plus 1. Now I take each factor, set it equal to 0, so 3x squared, make it equal 0, x minus 3, make it equal 0, and 2x plus 1, make it equal 0. So over here, if I divide by 3, I'm just going to get x squared is equal to 0. If I square root both sides, I'll get plus and minus 0, which is just 0. Right? Over here, x is going to equal 3. Over here, minus 1, then divide by 2. I get negative 1 over 2. Okay? All right, taking a look at number 5 here. So let's make the problem equal 0 first. Right? So minus x, add 1. Right? Then minus x, add 1. Right? So that's gone. I get 0 is equal to, just make sure it's in the correct order from highest exponent to lowest. So you guys have to recognize here, we have a polynomial with 4 terms, right? Remember, anytime you have a polynomial with 4 terms, we use the grouping method, right? So we're going to try grouping. So like I said, you have to use all the factoring and solving skills that you've learned from chapter 3 and chapter 4. Kind of combine everything together. So we use the grouping method. If you recall, we're going to group the first 2 terms together, right? So take out the GCF. Looks like it's going to be 4x squared. So we're going to end up with an x minus 1. Over here, it looks like I can factor out a negative 1, right? So then that'll give me x minus 1. Remember the grouping method, these should be the same if we're doing it correctly and we're able to factor it by grouping. Okay? So since these are the same, it gives me a hint that I'm doing it correctly. So then one of my factors will be 4x squared and then the minus 1. So you combine them to make one binomial factor. Then the x minus 1, you write it one time, right? Then you should recognize this 4x squared minus 1. That's a difference of squares. I can factor this more. This is 2x plus 1, 2x minus 1, right? Then I also have the x minus 1. Then take each factor, make it equal 0, 2x plus 1 equals 0, 2x minus 1 equals 0, x minus 1 equals 0. So minus 1 divided by 2, we get negative 1 over 2. Add 1 divided by 2, we get positive 1 over 2. Then add 1 to both sides, we get 1. Okay? Let's take a look at number 6 here. So first let's make the problem equal 0. So I'm going to add 35x squared to the left and minus 4, right? So I'll get 9x to the 4th minus plus 35x squared, then minus 4 equals 0. And then I recognize this is in quadratic form. Okay, I've factored something like this before. So I can use the x here. A times c, that's negative 36. B is 35, right? So what's going to work for me? It looks like 36 times negative 1, right? Divide by a, which is 9. I can reduce this fraction. This is going to be 4 over 1. So my factors are going to be, and here's where you need to be careful, because this is x to the 4th, right here, x to the 4th. So it's going to be x squared plus 4. And the other one would be 9x squared minus 1 is equal to 0. Okay? Now this x squared plus 4, we cannot factor this more. This is not a difference of squares, right? So it has to stay like that. Now this 9x minus 1 is a difference of squares, so we can factor this more. So you should. Now let's take all of these, set them equal to 0. So we get x squared plus 4. When will it equal 0? 3x plus 1. When will it equal 0? And 3x minus 1. When will it equal 0? So we're going to minus 4 on both sides. So x squared is equal to negative 4. Square root both sides. So x is going to equal plus or minus, this will give you 2i. Right? Over here, minus 1 divided by 3. You get negative 1 over 3. Over here, add 1 divided by 3. You get 1 over 3. Okay. Alright, so number 7 here. We need to determine whether x minus 2, alright, is a factor of this polynomial right here. Okay. Now the easiest way we will do this, alright, we can figure this out, is to use synthetic division. Okay. So when you want to determine if a binomial, right, in the form x minus like c is a factor of some sort of polynomial, right? You want to use synthetic division. And what you want is you want to try and get a remainder of 0, or see if you get a remainder of 0. Okay? So let me do this example here. So example 7a here, right? So I'm going to do synthetic division. So first of all, I'm taking, let's see, x squared plus 2x minus 4. So it's not missing any terms, so I'm taking all these coefficients. So 1, 2, negative 4. So if you remember synthetic division, so we're dividing by x minus 2, right? So that means that our c, right, is actually positive 2, the opposite of this, right? So if it's x minus 2, c is positive 2. So c goes in the box. Let's drop this down. 2 times 1, right? That gives me 2. Add, I get 4. 2 times 4, that's 8. Add, I get positive 4. Now what you care about is your remainder, right? If your remainder is not 0, that means x minus 2 is not a factor. So is x minus 2 a factor of this? No. X minus 2 is not a factor because the remainder, right, is not 0. Okay? I'm just explaining it so you understand why. Okay? Alright, so let's take a look at example B. Okay? So example B, we want to know if x plus 5 is a factor of 3x to the 4th plus 15x to the 3rd minus x squared plus 25. So first of all, this polynomial, I notice that it's missing the x term, right? So since it's missing the x term, right, I'm going to have to put a 0 in place of that when I do the synthetic division. Okay, so I'm going to take all these coefficients. So I have 3, 15, right, negative 1. Now it's missing the x, so I need a 0. Then I have the 25. Now I'm dividing by x plus 5, so that means my c is actually negative 5, the opposite, right? So my c, I'm going to put in here, negative 5. Bring down the 3. I multiply, I get negative 15. I add 0. I multiply, negative 5, right? I'm sorry, 0, not negative 5. I multiply 0 and negative 5, that gives me 0. I add negative 1, right? Multiply, positive 5, add 5, multiply, negative 25, right? So my remainder is 0. Okay, when you do synthetic division and your remainder is 0, that means that the binomial that you divided by, this x plus 5, that means that it is a factor of the polynomial. So x plus 5 is a factor. I'm just explaining why. Is a factor because the remainder is 0. Okay? So when you get a remainder of 0, that means that the binomial that you divided the polynomial by, right, is a factor of that polynomial. Alright, so the last thing we're going to talk about in this lesson is the rational root theorem. Okay, So the rational root theorem is used to make a list of possible real roots of a polynomial. Okay, so I'll talk about more in detail what this list is used for and why we use the rational root theorem in the next lesson. Right now, today, we're just going to focus on, so how do we make this list of real roots? Okay, so the first thing you want to do is you want to make sure the polynomial is in order from highest exponent to lowest. Okay, so the polynomial is in order here and it equals 0. All right, now what we care about is the coefficient of the highest exponent. So the highest exponent is x to the third, right? And then the coefficient is 1. So this is what we care about, right? And then we care about the very last number, which is just a constant. So in this case, it's 20, right? Now, what are the factors of 1? What are the ways to get 1? It's just 1 times 1, right? That's the only way to get 1. What are the factors of 20? Well, we've got 1 times 20. We've got 2 times 10, and also 4 times 5. These are all the factors of 20, okay? So I'm gonna give these kind of some variables. I'm gonna call all these numbers here, I'm gonna call them, all right, the p-values, and I'm gonna call all these numbers over here, right, the coefficient, the factors for the coefficient of the highest degree here, the highest exponent. We'll call these q, okay? So what you want to do is you want to help organize everything, right? We're going to make a list, make like a little box. So over here are going to be our p-values, over here are going to be our q-values, right? So q is only 1, right? So you don't need to put the 1 twice because it's the same number. And what are the p-values? The p-values are 1, right? And then we also have 2, 4, 5, right? 10 and 20. 10 and 20. And then what you're going to do is you're going to take the p, right, and divide it by q. So this is real simple here. So if I do 1 divided by 1, I just get 1. 2 divided by 1, I get 2. So basically 4 divided by 1, I get 4, right? So I'm going to get the same thing, right? And then whatever is in your box here, this is your list, right, of possible real roots. The only thing you have to remember though is you have to have a plus or a minus in front of all of these values. So your list of possible real roots is plus or minus 1, right, plus or minus 2, right, plus or minus 4, plus or minus 5, plus or minus 10, plus or minus 20. All right, so it could be a positive or a negative 20. Okay, so this would be a list of possible real roots of this polynomial. Okay, essentially what this is these are all possible answers to this polynomial here. Now we don't know what the answers are, but this is a list of possible answers to this polynomial. Okay, so in this lesson we're just going to focus on making this list. Okay, in the next lesson I'll explain to you what we're going to do with the list. Okay, all right, number 9 here. So we're going to find all the possible real roots. So remember, make sure that it equals 0 and the polynomial is in order from highest exponent to lowest. So what we care about is this 2, and we care about the 8. So what are the factors of 2? Well, it's just 1 times 2, right? And what are the factors of 8? It's 1 times 8, 2 times 4. That's it. So remember, these were like our p-values. These are our q-values. So we're going to set up our... All right, and notice there's 2 q-values, right? So I'm going to make kind of a table. I've got 2 q-values, right? So I've got 1 and also 2. So these are my q-values. Then the p-values, I've got 1, I've got 2, I've got 4, I've got 8. So remember, I'm going to take all the p-values divided by q. So I'm doing p divided by q, right? So 1 divided by 1, well, all of these are going to be the same, right? So 1, 2, 4, 8. Then when I take the 1 divided by 2, I'm going to get what? 1/2. Right? What's 2 divided by 2? 2 divided by 2 is 1, right? So I already have the 1 there. So you don't need to put it again. I mean, you could if you want. 2 divided by 2 is 1, right? 4 divided by 2 is 2, right? 8 divided by 2 is 4. So these that repeat, you actually don't need to write it again. All right, you could if you want to. So what's our list here? It's going to be plus or minus. We've got 1, 2, 4, and 8, right? And then we have the 1/2. And then we don't need to write the 1, 2, and 4 again because we've already written it. So this would be your list right here. So it's plus or minus all these values right here. Okay, you could just write the plus or minus one time in the front here. That's perfectly fine. Okay, just make sure you understand that all of these values are positive and negative. Okay. All right, let's take a look at another example. Right. So we're going to find the possible real roots of this polynomial. So first of all, always make sure it equals 0, just in case it doesn't, and make sure it's in order from highest exponent to lowest. Right. So all we care about is the coefficients, all right, of the highest exponent, which is 4, and the constant, which is 3. Okay. And then what are the factors of 4? Well, it's 1 times 4, but we also have 2 times 2, right? What are the factors of 3? Well, this one's kind of nice. It's only 1 times 3, right? So remember, these are like our p-values. These are our q-values. So how many different q-values do we have? We actually have 3 different numbers, right? So when I make the table, I'm actually going to have 3 different numbers, right? I have a 1, I have a 2, and also a 4. These are my q's. Then the p's will only have 1 and I only have 3, right? So you can make a table like that. So if I take p divided by q, so p divided by q, 1 divided by 1 is 1, 3 divided by 1 is 3, 1 divided by 2 is 1 over 2, right? 3 divided by 2 is 3 over 2, 1 divided by 4 is 1 over 4, 3 divided by 4 is 3 over 4. So my list is going to be plus or minus. So find all the different values in this table. 1, 3, 1/2, 3 over 2, 1 over 4, and 3 over 4. So this would be our list of possible real roots to this polynomial. Okay?